Welcome all to today's lecture. Myself Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College. And the subject I am covering lectures for is microprocessor and microcontroller. Code is KEC 502. So today I am going to introduce you all to the term microcontrollers. We will study some details about the microcontrollers. So let's understand what is the difference between a microprocessor, a microcomputer and a microcontroller. So as we have already studied that microprocessor is the CPU on the single chip, or we can say a processor on the single chip, and it consists of arithmetic and logic unit, registers and control unit. Then what is microcomputer? So if we add along with the microprocessor, if we add input-output devices, memory units and peripheral devices, then it is termed as the microcomputer, or we can say a small computer. Now, next term is microcontroller. When we have this microcomputer which is having a microprocessor, that is ALU, registers and control unit, input-output logic devices, peripheral devices and memory units, all these together on a single chip. Then it is known as the microcontroller. So we can say all the devices, that is microprocessor plus input-output logic devices, peripheral devices and the memory units together present on a single silicon chip makes microcontroller. We can understand this using a diagram also. So let's see. So a microprocessor system contains 6 basic components. So we are talking about a system. ALU unit, register array, control unit, memory, input unit and output unit. So we have already studied that this is microprocessor, having ALU, register array and control unit, input-output unit and memory unit along with the system bus. This whole arrangement is known as the microprocessor system. Now, so we can say a microprocessor is a CPU on a single integrated chip, or we can say a special type of CPU, or we can call it the brain of the computer. The examples of some famous microprocessors are 8086, 80286, 386, 486, Pentium, Core 2 Duo, Core 2 Quad, K5, K6, Athlon 64, Opteron, Phenon, PowerPC G4, PowerPC G5, Xenon, Broadway, Cell, and list is unlimited. So these are certain famous microprocessors which we come across nowadays in today's gadgets. It contains no RAM, no ROM, no input-output ports on the chip. So this is the specialty of microprocessor. It contains no RAM, no ROM and no input-output ports on the chip. The figure shown here is just for a reference. So such chips are available in the market. Now we talk about the microcontrollers. So we can say on a single chip, when all these are available like CPU, memory, input-output, and subsystems like timers, counters, analog interfaces, and input-output interfaces. So, all these present on a single chip makes microcontrollers. So, a microprocessor, RAM, ROM, input-output ports, and timer present on a single chip. This is known as the microcontroller, or can be denoted by this term. Or we can say a computer on a chip. So, generally, we call it as a microcontroller unit, MCU. Usually not as powerful as general purpose microprocessor. Low power consumption, small in size, low cost. A lot of MCUs are application specific as against the general purpose microprocessor. As we can see that a microcontroller is having a certain amount of memory, certain amount of input-output ports. So, according to our application in demand, we can adjust the size of the memory, the size of the input-output ports, and so on. So, we can say that we can design a microcontroller specific to our needs. So, this is not a generalized device as unlike the microprocessor. Microprocessor is a general device. We can perform many operations using microprocessor, but the flexibility with the microcontroller is very limited. So, let's see the difference between the microprocessor and microcontroller. Microprocessor is having the several instructions for moving the data from external memory to CPU. Microcontroller is having 1 or 2 instructions for moving the data from external memory to CPU. In microprocessor, few pins are multifunction, but in microcontroller, large number of pins are multifunction. Designer can decide on the amount of ROM, RAM, and input-output ports, and microcontroller is having the fixed program and data memory. Microprocessor uses different ICs for memory and input-output functions, but microcontroller consists of the inbuilt memory and input-output ports. Microprocessor is having no inbuilt timer, but microcontroller is having its inbuilt timer. So, these are few basic differences which can differentiate microprocessor and microcontroller very easily. So, the commonly available microcontroller families are Intel 8051, Atmel AVR, Microchip PIC, Texas Instruments MSP, ARM is manufactured by ARM itself, and Motorola 68HC08/11. So, these are some general microcontroller families available in the market. So, many microcontrollers are existing right now: 8051, 68HC11, MSP430, ARM series, and so on. We may widely divide them into different categories based on different parameters, like based on how it is designed, we can categorize them as RISC and CISC architecture. We have already discussed in the previous lectures that the RISC means reduced instruction set computer systems and CISC means complex instruction set computer systems. According to the RISC architecture, we have suppose we want to we are having the simple instructions which are capable of performing different operations, simpler operations. But according to the CISC architecture, that architecture is having the complex instructions. Like a single instruction can can execute different complicated operations. So, in this way, in that architecture, complex instructions are present. According to the manufacturer, these can be categorized as Atmel series, Intel, Microchip series, and Philips series. According to the read-only memory technology, what type of ROM is being utilized? According to that, we can categorize our microcontrollers as programming serial or parallel. According to the ROM and the RAM capacity, we can categorize our microcontrollers again. Other features like ADC or DAC, watchdog timer, timer and counter, number of input-output ports. According to these different features, we can categorize the microcontrollers. So we can see that according to the design of the architecture, like RISC or CISC, according to the memory type like hardware and von Neumann architectures, according to the manufacturer details, according to the ROM and RAM capacity, and other features, other features of peripheral devices, we can categorize our microcontrollers. So this is the list of some common microcontrollers used. Like we can see under the Intel, we are having these many microcontrollers, like 8-bit microcontrollers are there, and again 16-bit microcontrollers are there. Again, this is the next company. Microchip is having the 18-bit instruction pick, 14-bit instruction pick, 16-bit instruction pick. Then NEC. Next, Motorola. Motorola is having the variety of microcontrollers under the category of 8-bit, 16-bit and 32-bit microcontrollers. Texas Instruments is again having a variety here. Zilog is again having a variety of microcontrollers. So in this way, there are a series of and there are a variety of microcontrollers available in the market today. So how do we decide which microcontroller to use? So there are different parameters which helps us in finding out which microcontrollers fits to our need, fits to our application needs. So first is one of the speed is one of the option here. Next is the power consumption. Next is the amount of RAM and ROM on the chip. Next is the number of pins, cost per unit, and the packaging. So these are the 6 parameters. And based on the analysis of these 6 parameters, we can decide which microcontroller is best suitable for our needs. Here I have differentiated 2 common microcontrollers present nowadays, and we can see the differences very clearly. According to the clock speed, 8051 is having 12 megahertz of clock speed. Pentium is having 1000 megahertz of speed, that is 1 gigahertz. Address, 8051 is having 16 bits of address. Pentium is having 32 bits of address. The size of the data bus for 8051 is 8 bits and for Pentium is 64 bits. Again, the width of the ALU is 8 bits in case of 8051 and 32 bits in case of Pentium. Next, applications. The applications covered by 8051 are the domestic applications, peripherals, automotive, etc. Rather, simpler applications. On the other hand, Pentium can support complex applications also, like personal computers and other high performance areas. Power consumption. In terms of power consumption, the small fraction of watt is consumed in case of 8051. On the other hand, tens of watts are consumed in case of Pentium. If we talk about the chip, the cost of the chip, about 2 euros in volume is there in case of 8051, and about 200 euros depending upon the specifications are spent in terms of Pentium. So we can see that there are certain clearly visible differences between the 8051 and Pentium series. In terms of packages, we can see there are different packages available in the market. The most commonly package we see in today's labs is the dual inline, and that is the plastic dual inline package, PDIP. Next package is a PLCC, that is a plastic leaded chip carrier. And another one is the thin quad flat package. So the variety of packages are available in the market, and we can select the desirable one according to our application, according to our need. So we can conclude there are 3 criteria in choosing a microcontroller. First of all is meeting the computing needs of the task efficiently and cost effectively. That is the speed, the amount of ROM and RAM. the number of input-output ports and timers, size, packaging, power consumption. So these factors play an important role in selecting the microcontrollers. Next very important point is that it should be easy to upgrade the microcontroller. That is, if the programming has been done for a certain microcontroller, and if you want to upgrade that your device by replacing the microcontroller with the higher available version, then that compatibility should be there, that no need to make any changes in the programming. Next important point is the cost per unit. This is very important factor when manufacturing in bulk. Availability of software development tools, assemblers, debuggers, C compilers, simulators and technical support. This is very important. Without this, we cannot make any of the application in embedded systems. Wide availability and the reliable sources of microcontrollers. This is yet another main feature which is very important to make a decision in choosing a microcontroller. So we can conclude that there are different architectures of microcontrollers, like von Neumann and Harvard architecture. In von Neumann architecture, the program and the data memory are present in the same space. But in case of Harvard architecture, it uses the physically separate memories for their instructions and data, requiring dedicated buses for each of them. So the instructions and the operands can be fetched simultaneously. Different data and program bus widths are possible, allowing program and data memory to be better optimized to the architectural requirements. We can see that the data memory and program memory are different in the same, which are connected to the CPU through different data and the program address buses. So this is the difference between the von Neumann and Harvard architecture. So in today's lecture, we can conclude that we studied the basics of the microcontroller. We studied how to select an appropriate microcontroller according to our application, how we can categorize different microcontrollers based on the architecture, based on the memory size, based on the architecture of the memory, and also based on the different peripheral features. So there are basically 3 criteria in choosing a microcontroller. Microcontrollers are available in different packages. There are commonly available families of microcontrollers in the market. So these are few among them. So today we have covered the basics of microcontroller, and in subsequent lectures we will move towards a very basic microcontroller and very popular, that is 8051. So we will see the details of that microcontroller. So that's all for today. Thank you.